I'm legging up 2 chairs today, and I'm doing something different with the legs than I usually do during classes. Almost every stick chair I've ever seen in my whole life has cylindrical tenons, and when I teach, I normally use these tapered tenons. Why? Is there a difference? Does it matter? The tapered tenon takes some extra tools to make, which makes it more complicated, but at the same time, it's more forgiving. You get to ream the hole for the tapered tenon, and you get about 4 or 5 chances to get it right. With a cylindrical tenon, you only get 1 chance to get it right, but you don't need a lot of specialty tools. We're gonna need just a 1-inch drill bit. This is a wood owl drill bit, and then we can make the tenon with a tenon cutter or on the lathe. So it's a little different than making this tapered joint. So if you've never made a cylindrical tenon, it seems simple, but here are some tips to help it go a little easier. A lot of the things are just the same when you do a tapered tenon. We have a backing board, we have the seat with the front legs hanging off the front so we don't drill into the workbench. And I'm clamping this down with a couple F-stiles, but then we also clamp back here to get the backing board even tighter onto the seat so that this doesn't flop around when we drill through the seat. Especially if you're not going to saddle the seat. This is really important. The other thing I do is, just came to me at one time, to use the laser that we use for drilling the mortises in the arm and into the seat, to use it for also doing the legs. So here I have put this green laser right on the sight line, and it's just shooting right up that sight line and into space. And now I have a sliding bevel, which I'm also going to put on the sight line, and this is a 25-degree resultant or drilling angle. And the first thing I'm going to do is I'm going to set the worm with the drill so that it doesn't skitter forward when I begin drilling. I'm going to bring the bevel up to the drill bit, up to the auger. And now if you look up here at the top of my drill, this is the great thing about the laser, is that I can see the laser going on the seam of the drill, and that really helps me stay on my sight line. And then the last thing I'm going to do before I start drilling is I am going to try to absolutely meld this drill to my body. And that means, this battery is pushing into my hip, and I am going to, with my hands, try to stop it from rotating. And what I mean by not rotating down here, but rotating up here. So if you get going too fast, the drill bit will start to rotate you like this, and that's when you go off. So I find that the more I can control the drill body, the better results I have. So let's go and see what happens. So I get about 1/3 of the way through, and I can still make some small adjustments here, and then I'm going to put the bevel onto here, and I can see that I'm leaning back a little bit. And I also need to lean to the left a little bit. So back and to the left will get us there. The slower you go, the easier the drill is to control. Okay, now I need to go forward a little bit, overcompensated. All right, last check before we go. I am pretty much on my sight line and just a wee tad off on my drilling angle. So I'm just going to come back just a little bit more. Okay, so that's one, and now we'll do the other 3 pretty much the same way. So that's it. It's much faster than drilling a pilot hole and then reaming the tapered hole, but it is a little more risky. So now all I have to do is I'm going to turn these 1-inch tenons, cut a kerf in them for a wedge, and then the legging up process will be complete.